it is my great pleasure to introduce Mercè Crosas. Mercè is here. She's the Chief Data Scientist and Technology Officer at the Institute for Quantitative Social Science at Harvard University. She's more than 10 years experience leading the Dataverse project, more than 15 years experience building data management and analysis systems in academia and biotechnology companies projects. Many of you will be familiar with, like the NIH Data Commons, Harvard Privacy Tools, data tags, data provenance, and the Structural Biology Grid Data Bank run out of Harvard. So really pleased that Mercè was able to join us at this conference. We tried to get her for previous years and scheduling didn't allow that. And so we're quite pleased that she's been able to travel all the way from Cambridge, yes, today to be with us. So thank you very much.
Thank you, Nancy.
Sure.
I'm gonna set up here and I'm delighted to be here. Okay, good idea. And I can use this.
Yep.
Okay. Can you hear me well? So yeah, thank you everybody. I'm very happy to be here. As I was mentioning Nancy a little bit earlier, often I think that I already talked to everybody in science and technology about data access, data reusability, data sharing. And I'm always happy when I find a new community that I can have new conversations with. So I have a lot of new faces here I haven't met before. So I'm happy to share this with you. So I'll get started. I think the title of my talk was much longer than just Dataverse. I simplified it, but I will talk about addressing new challenges in data sharing. But I want to make sure that first, I don't know, this is not moving. Oh, okay. Okay. Maybe this doesn't move. If not, I'll use this one. Yeah, there you go. Okay. So I first wanted to make sure I introduce what Dataverse is about. And Dataverse in some ways is many things. For some of the users that are using Dataverse as a repository, it's a place where they can deposit data sets, they can find other data sets, they can cite those data sets. For some institutions, organizations that use Dataverse as a platform, is the open source software that helps them connect between data depositors or data providers and data consumers, and they build their own repositories. But also Dataverse has become more and more a community. And I will start talking more about the community aspect of it because I think it's one of the important things that this project in the last 10, 12 years has brought to data sharing. So we do have a really growing and engaged, very vibrant, active community. We have sites, Dataverse sites, Dataverse repositories that each one might support multiple Dataverses might host many repositories within one of those sites. And there are 33 sites around the world and in many places, most of the continents. We're very happy about that because we can reach out to folks and to countries that usually are not, they're not very as acquainted with data sharing as well, here in the US or some other countries in Europe, but we've reached out to Central and South America and to some Asian countries. This has been first a slow growth, and now in the last years, we've seen a rapid growth. For any of you that have been already involved in data sharing in the last years, or in just making data more accessible, you probably have noticed that in the last 5 years, there is a lot more awareness of the importance of that and making data as open as possible and as restricted as yet, but made it as accessible as you can make it to advanced science and to make it reusable, right? And there is a lot of investment in collecting data, in cleaning and curating data. So making those data sets be used by other researchers is an important part of what we do when we do science. So, but in 10 or 12 years ago, I mean, right now I'm invited a lot more talks than 10, 12 years ago, let's put it this way. It was not that many people that wanted to hear about data. They were saying, no, why am I gonna do that? So it's been very nice to see that growth. When we started developing the Dataverse at the Institute for Quantitative Social Science, was an initial focus on the social science data sets. And then we grew into biomedical data sets, astronomy, astrophysics data sets, and we basically now support data across all disciplines. But it started with two sites, one at Harvard University and one at the University of North Carolina in Chapel Hill, is the Oldham Institute. And we had a few developers just within IQSS. Then over the years, we grew to just increase the open source community and brought contributors from other sites that were installing the Dataverse software to just, well, develop and add features to the code. And we have now 74 contributors. So it's been growing, as you see, from 2015, we have 14 sites around the world, then 18 in 2016, 23 in 2017. And this last year has been the biggest growth with 10 more sites around the world. And we've had already, well, 30 releases during all this time. Well, 12,000 or more commits you can see in GitHub. So it's really nice to see that community expanding and also so engaged into contributing to the project. So we were able this year, just in last couple of months, release a new organization that it's the Global Dataverse Community Consortium. And we're leading this with, I don't know, this is from the Zoom, right? Okay. So so we're leading this with John Crabtree at the University of North Carolina and Peter Dorn in the dance in Holland. In the dance is the Dutch National Archive. So the three of us are in this consortium, and we have already participants, I think 15 or so participants around the world, different universities. And we're gonna release this, launch this website. And the idea that, I mean, just very, I think in the next month or so, but the idea of this consortium is to be able to support the community now, this international community with the Dataverse platforms. How do they set up? How do they build their repositories? What do they need for data curation? Any services that are needed to host a good data repository, right? That follows principles such as the FAIR principles, for example. The data is findable, accessible, interoperable, and reusable. So what does it take to build the active community, this engaged community? So I think I would summarize it in three main areas. One is we need this transparency and what I call, and psychologists call, the common knowledge, to have openness about what we do and a good understanding and a good message and vision for where we're going, what are our goals, and what is our roadmap, and so on, that be shared with the community, right? So everybody knows what direction the Dataverse project is going. That applies, I think, to many open source projects. We need the right process and tools for that. And what I would call a human touch, or some in-person, face-to-face communications also. So we establish this transparency and common knowledge by first having in our website very clear statements about what is our roadmap, what are our strategic goals. If you go to dataverse.org, you can find that. Then we use Waffle to again, transparently show what is the development process. What is the status of everything? We have included here a board in the Waffle board, one of the boards for the community development, so that we see the community can participate into that, and when they take GitHub issues, they can it can go into the part of the community development, and they go through the process with the development that is happening, the core development that happens at IQSS, at our institute. And we keep, obviously, general, discussions, open discussions was in GitHub about issues, or discussions in our groups, mailing list. I imagine many of the open source projects do something like that, but we're really engaged into doing this. We respond quickly to how, to our participants, to our contributors, and be able to, they do feel that there is somebody else there listening to them, and we can help them go through the process. So with that, we establish, since we do agile software development, we use a process and use the tools that help us with that. And one of the things that you can see in this waffle board is that we have the process here set up clearly within the board, so that we know that what is all the backlog of all the GitHub issues that we need to work with, all the new features or bugs or so. What is the community development? We give a lot of importance to UI and UX. So that's one section or one stage in the process that it is important to start usability, to engage the contributors, the project already, not only with the technical design, but also with the usability part, and run user testing, do usability research at the beginning of the process instead of just at the end. Although very often we do it also at the end, once the feature is developed, and so that we can get feedback again from the users at that point. But then do the 2-week sprints, right? And whatever is ready goes into that sprint. There is also the core development and the code review that is done by the developers, the technical lead in our institute. And then obviously formal QA and so on. So we're ready for releasing. So, what is the human touch? I mean, like in this conference, having a face-to-face meeting is important. To use all these processes and tools that facilitate working with folks in China and folks in Brazil and so, but at the same time, having once in a while a meeting that is in person is very important. And we've been doing for the last 4 years these annual community meetings at Harvard. And now there are other groups in other places in the world that have solicited to do a semi-year, more times a year, to do other community meetings that they will host in their by the organization. So this is growing too, and we have usually a very good representation of many countries. And we also have bi-weekly calls so that people can talk to the team and figure out what is that, if there is any problem with the development of something or some request for a feature, they can talk to the others in person. And also important, we have a Dataverse World Cup, so where some of us are soccer players, and we organize the Dataverse World Cup, and when the folks come from all over, from many countries, they participate in this soccer match. So I started with the community because I thought, I think the community is a big part of what makes Dataverse, the Dataverse project, a successful project. But I want to go into now what are the features of Dataverse, what do we provide, what is the data, what type of data we host, and what data can be shared with the Dataverse platforms, and then some of the ongoing projects that are the ones that are just addressing these new challenges, right? And that we're very excited to work on. So I mentioned already that usability was a big part of it. So we provide a rich set of features, but with a focus on user-friendly features. The UI is important for us, and the usability is important. So one of the features that Dataverse provides that was part of the motivation of building a project like Dataverse is provide incentives for data sharing. And to do that, one of the things that we do is that we generate automatically a data citation, a formal data citation that follows the joint, what is it called? The joint declaration of the data citation principles, data citation principles that were generated or created by a large group of participants led by Force 11 organization. But that means that it follows these principles so that to make sure that data authors or data creators are give credit when they are in the data citation. So they has to be formatted, the citation formatted in a way that that's similar to a publication that again the authors, those that either provided or created the data get attribution. It has to contain what repository is that, a persistent identifier that often is a DOI, a digital object identifier that would be able to resolve to a landing page of where the data set is. And there in the data set page, have all the metadata to be able to understand what is that data set about, how to access the data directly. And also it includes specificity of what is the version, what is the, what are you referencing, what data set, either version or a timestamp to reference the data that you used. And provide to facilitate the use of the data citation, we provide these, well, just that easily you could download the citation in different formats. We also give a lot of importance to metadata. So metadata is important. I mean, the data files are a big part of the data set, but then the metadata that is associated with those data files important for being able, for discoverability, for being able to find those, the data sets and be able to understand the data sets and reuse them. So that means that metadata needs to be at different levels. It's not enough to be just the citation metadata or the descriptive metadata that would make it findable, but it also has to have enough information to make it reusable. So we allow for these custom metadata blocks where you can add additional metadata fields to be able to describe how the data set either was collected, how it came about, what were the participants, what are the variables, is there a code book that's associated with it, and so. And we extract automatically the variable metadata from tabular data files. So Dataverse, when it ingests or after uploading a data file, we'll go through a process to get the column, the headers of the columns that, depending on the format, will get more or less information, and depending what is there usually in the file, right? And then support different metadata standards, like the Data Documentation Initiative is any of you are familiar with with the DDI? It's used mostly in social science, but it actually applies to data across all many disciplines. It allows for a lot of detailed information about the variables of a tabular data set, and about a statistical metadata also associated with the data set. And link core and schema.org. For schema.org, any of you have recently seen the Google dataset search? Yeah. It's just they just launched it. Yes, so they've launched it a few weeks ago. And I mean, it's still in beta and still is missing a lot of the data, but the nice thing is that it just very easily, as repositories and data centers and data stewards and so become familiar about what to do in order to be indexed by this Google data set search, it will become discoverable across any data repository. So for doing this, you just need to embed the schema.org in a JSON LD. Well, there are other ways to do it. The easy way to do that is just embedding it in the dataset page. This is a schema.org JSON LD as a markup, well, embedded in the HTML, and then Google knows to search, to index this as a data set. And it has, so schema.org has one of the types that supports is a data set, and the fields that are supported there relate to metadata about a data set. So you can find a lot of the data sets in Dataverse through already have been indexed through this Google dataset search. And another thing that is important is that data, like publications, that usually are just one-time release and published, and that's it, unless there is a change. They never, they become static. But for data, it's still changeable, right? It still might be new versions of the data. So it is important to support the version so that even once it's released the first time, and you can cite that version, right? The original version, because might be the one that you used in a publication or you used in the results of a study. You still want to create new versions of the data set and make improvements, add metadata. So we're allowed to this flexible versioning of releasing new versions, whether they are minor or major versions. And if it's a major version, it becomes part of the citation, because major versions mean that the data itself, not only the metadata, but the files have changed, and want to make sure that the citation then would point to would resolve and point to the right version. The other thing is that important, that even though we really, well, we promote open data, because whenever possible, like the Open Science Initiative say, that when, as I mentioned before, also that data should be as open as possible, but as restricted as needed, right? So if it is possible, let's make it open, and we have that as the default, so that researchers know that if, well, they will get credit for sharing those data sets, others will cite the data set, right? It will be cited in the publication that the data set is used from, but still making it accessible to everybody. But in some cases, that's not possible, and that's where we allow this tiered access, so that you can choose, you have control, even though you deposited the data to a repository, you still have control over your data, because it is your data, you know how to manage it, you know when you have to create a new version, and you know who should access the data. So in this case, you can restrict the files that cannot be accessed unless you go through, well, the data user or the data consumer goes through either a terms of use or signs a data use agreement, or there is some, or maybe it's restricted just to your collaborators in your organization or so. But still the data is findable, so you still can have that descriptive metadata open, so that either the Google dataset search or other search engines that exist and that will be built can find those data sets and know they exist, and they understand what would need to be done in order to access the data. So also Dataverse supports well, managing the users that you have access to the data, so you can track and audit who has access and who cannot have access after a certain point. And this could be established by version. So another interesting feature of Dataverse is that since at the time of uploading a tabular data, we extract this variable metadata, the metadata about for describing every column in the table. Then, for example, those data sets might be uploaded using an R data frame or an SPSS file or Stata file or CSV or an Excel or so. So depending on how much information this the original file has about each column and describing what every variable is, the more we can do with this information and create summary statistics or descriptive statistics on the. So then this can be used to integrate with this data explorer that we actually haven't built, but a group in Canada of about 14 universities that are using Dataverse have built this data explorer that allows to look at the tabular data and see for every variable what is the distribution, what are the summary statistics, right? And understand the data more even before downloading it. And so So it gives all these, all the metadata allows to give all this additional value to the data set. And there are several other data explorers that have been created. One is called to Ravens and so on. They can be integrated also with Dataverse easily through the API and by using this extensive metadata. So another one of the features is that, for example, that also at the time of upload, Dataverse can extract the header information of a FITS files, the FITS files that are used in astronomy, if you're familiar with those, and they might have information, depending on how they've been collected. It might have information about the instrument that it was used, about ascension and declination, and any other information about that measure, when it was done and how it was done. So this is important information that can be extracted automatically and become part of the metadata, is then searchable, and it helps also understand the data even before downloading it. So another feature of Dataverse that have made it very attractive to different groups that they want to have a repository, but they still want to brand it and customize it and manage it in the way they want it, is that we allow for all these customizations. So you can have a Dataverse that you can even use a widget to embed it in your website, or you can just brand it as you want. I'll show more examples of these with the different data that the data sets that types of data that we support. And finally, within features, we have a very extensive API. Some APIs that are standards like sort. I don't know if any of you are familiar for an API for data ingest, for the data deposit from one digital repository to another, for example, but also, well, an extensive search API, and just an API for doing anything, either creating a data set, depositing a data set, accessing the data, and so on. And that has allowed to integrate with a bunch of different tools and other platforms. So I don't know if you're familiar with the Open Science Framework, is one of the projects that we integrate with. The Open Science Framework it was created by the Center of Open Science, and it helps organize your research project and manage all your files and so on. So once you have data sets that you want to publish from the Open Science Framework, you can publish directly to Dataverse. The same type of integration we have with an open journal system, as an example of one integrations with journals that it allows us to, well, for those journals that use the OJS, they can, when they accept a paper, they can ask for the data, and the data goes directly into the Dataverse repository. So the journal manages the article, and the data goes to the repository, and it's managed there. So then RSpace, for example, is one of the examples of integrations with electronic lab notebooks. And also, so if you maintain all your files in an electronic lab notebook, at some point that you want to release that data, make it shareable, make it accessible to a larger group, you can, with a button, just submit that data to a Dataverse repository. We also integrate with the World Map as a GIS system for data that has geospatial information, with Dropbox, with ORCID, and this is just a subset of the examples. So any questions so far? I continue? I'll leave time for questions at the end, but there's quite a bit of material. So, well, let's talk quickly about data and what type of data we support. So we'll talk about dataverses that are used for journals, dataverses that are created by a researcher, an individual researcher, by a research community, or by one or multiple universities, right? So first, just to introduce the Dataverse for journals, in the last year, we did a study for social science journals. And I would be interested to compare these with studies in journals in engineering or in biomedical and so, but this was a very extensive study, quantitative study that took the 50 top journals of 6 different disciplines. I don't know, you might not be able to read the disciplines here, but there's anthropology, the first one, economics, history, political science, psychology, and sociology. So the red bar shows the percentage of those top journals that did not have any data policy, did not ask authors to deposit the data or to provide the data at the time of submitting a paper. The blue bar is that they, are those that suggested, very well, strongly suggested to, or encouraged to make the data accessible, but they didn't require it. And the green one is that they are required. So for economics, psychology, and political science, those are the ones that are more strongly require the data policies. I think it has, has been that within those communities, there have been leaders that have driven that movement, right? And they have made that possible either within their own societies or they're working closely with the publishers. So, but in general, for anthropology, economics, psychology, and political science, more than 50% of these top journals either encourage or require the data associated with the article. So that's a big growth compared to 5 or 10 years ago, where most of the journals did not ever require, only for some of the biomedical journals in genomics, so that require, for example, the data in GenBank, or those are the ones that started in the 80s and 90s to require this. But now within social science, we see that also this is taking place, and it's really nice to see the growth in the last years, right? So we work very closely with some of those journals and also with journals in not only within social science, but it just happens to, that we have a relationship with a lot of the social science journals, but we work also with journals from law school, from biomedicine, from different groups. But right now in the Harvard Dataverse repository, we have 80 Dataverses. We host the 80 Dataverses or sub-repositories, right? Virtual repositories that are for different journals. I put an example from the American Journal of Political Science, which might be a journal that none of you ever read, given the audience. But it's actually very quantitative, and they provide often not only the data, but the data and the code that goes with the data, whether it's an R script or Python script or Stata or do file or so, but a script that comes with the data set that it's supposed to help produce the results from that are claimed in the results of the article, right? So this is one of the examples of the journal not only requires the data and the code, but they also have a third-party group, which happens to be in the University of North Carolina, with the Odom Institute there, that serve as the data reviewers, and they check that all the results reproduce well, computationally reproduce well. So, and they have a lot of stories of how many times they have talked to the authors to ask for either descriptions about it, that the data is not well formatted or that the code doesn't work. So on average, they go back 3 times to the authors to ask for that, and then finally get the right results. And usually it's not any bad intention from all researchers. I think that everybody wants to do a good job, but even if you think yourself how many times you go back to your work and try to rerun it, and it doesn't happen, right? So I think that getting that into practice, it helps these authors to be more conscious of that and document. Well, hopefully it will help them document the code and data more accurately, so the next time they don't need to go back and forth, right? So here, just a quick example of also you could use a Dataverse within the Harvard Dataverse repository. You could create a virtual repository for your own data, and just random researcher that has created a Dataverse for his data sets. And another example for research community that are using Dataverse for the data set is the structural biology community, the SB Grid data bank. Basically, it uses as an underlying technology, Dataverse, and it provides access to all the images from structural biology and how it connects to the protein data bank data with using this platform, right? And it can provide the metadata, and can provide all the, they added a lot of features that work for them that I'll show you in a little bit. Just an example, I'll show you here. In Texas, there are 21 or so, I think, universities that are part of a consortium for Texas digital libraries that use Dataverse for all the research data associated with all these universities as an institutional repository to deposit the data and be able to make it accessible to either a community or within the university. So that's one of the other examples of Dataverse sites. And in particular for the Harvard Dataverse, since it's open to the entire research community, to any research in any place in the world, it has grown significantly over the years. We have now, in terms of data sets deposited directly to Harvard Dataverse, are 29,000 with, I think, 300, maybe, I don't know, it's 300,000 files or 400,000 files. Those are the ones that are deposited in Dataverse. We also harvest, by just harvesting the metadata, to make data sets searchable from other repositories. So we have a total of 50,000, almost 60,000 data sets that you can find through the Harvard Dataverse. And that has been in the last year about 250 data sets every month added to this repository. There are 4 million downloads, about 150,000 downloads per month of the files. So those are downloads of the files in the. Every data set might have 1 or 100 files, so just to get an idea, or 1,000 sometimes. So let's talk about, still have some time, right? Talk about the projects. What are the ongoing projects? So some of the issues that need to be addressed in general for data sharing, but in particular in Dataverse, started to support mostly from small to medium-sized files, also files that mostly didn't have any sensitive information. And so we're expanding to support all these other types of files that come with big data, and come with complex data that even though sometimes you have to identify the data file, you still could merge or combine the file with information that you find from other data sets and make those data sets identifiable. So it becomes more important to support not only large data, but sensitive data. We also have some projects that we want to make sure that the quality of the data is good, right? So it's not only important to make that data accessible and to promote data sharing, but we also need to make sure that it will be reused. I mean, there is a lot of times a lot of emphasis in the reproducibility part, but even if what we aim for, or not only even more important than what we aim for, is that we can reuse it ourselves in our own lab in 5 years from now, and that we can, and that other labs or other research groups can reuse that data too. So it's what will help advance science, right? So often, I think, well, underestimate, maybe that's the right word. I underestimate how much effort it takes to document a data set so it is reusable by somebody else. And not only the data set, but the data set and the code associated with that data set, right? So I think, well, that's one of the aspects that we're working on. And the other one is that is a project on creating an open source health index. So I'll talk about all these projects that are ones that we have we've had funding just recently. So some of them started a while ago and they're going on still and growing, and some we just got funding in the last month or so. So for the large data, we've been doing a lot of enhancement Dataverse to support large data, mostly in collaboration with the structural biology grid, with Piotr from the Harvard Medical School. And that has allowed us to just not have only deposit of data through HTTP, which obviously is limited for large data files, but also through rsync, and we're looking at other ways to bring the data into the repository, or having the repository and the data catalog point to the data instead of uploading the data, right? And we have more ways of accessing the data so that you have a data replicated in different locations, so you can just access it locally. We're also integrating with, so that when you go to the data set in Dataverse, you could just click a compute button and be able to have multiple options of where you want to compute that data set, and not have to download the data, but go into either the institutional research computing portal, or maybe Science Gateway, I should call it. Or a cloud vendor, or any other computing resource where you have access to the data, and that way avoids this data download, but also you go where you have the data where all the tools for doing the computing are, right? I added this about integrating with Globus transfer because yesterday from one of the tutorials on Globus, and what is one of the things that we've been having discussion with that group to see an integration with tools like that to allow the data to be accessed in multiple locations. We've been also working within Harvard group in the Massachusetts Open Cloud, which includes 5 universities there in Massachusetts, right? Harvard, MIT, BU, UMass, Northeastern, I think. So, and just to integrate with this open cloud, which is built on top of OpenStack, and be able to access the data from there. So we're working on moving the Harvard Dataverse to this open cloud, basically, this year. So in terms of supporting sensitive data, we've been working on several side projects that are now getting integrated with Dataverse. So one of those projects is called the Data Tags Project. There is a paper with Latanya Sweeney. I don't have the reference here, but Michael Barth and I, where we, as my co-author, where we published these data tags levels. And the idea here was to standardize the access and the security requirements to data sets. So if we're talking about sensitive data, many institutions have been creating their own levels, or their own different standards, but should we have a global standard that would help to more easily to interpret and to work with other, from one institution to another. So that was the idea of data tags. And every level has a color from blue to crimson. Crimson, we never get there. We're not planning to support that now. But most of the data that are sensitive are orange or red. That means like HIPAA data, the FERPA, I mean, some data that falls in, or FISMA, that falls into one of those regulations, data regulations, right? And just making sure that we understand we have the same language to how we share data sets across different systems by using these tags. And these data tags have a set, well, it can be described as a JSON file with all the sub-tags that define what are the requirements for security, the requirements for accessing the data. So we are working very actively now integrating these with Dataverse. So when you deposit a data set that is sensitive, contains sensitive information, you can maybe together with the IRB or Institutional Review Board, you can assign the appropriate data tag, and then the repository guarantees that it will be stored and accessed in the way that, and tracking all the, well, the logs and all the audits that are needed to corresponding to the data tag that you assign that data set. So, and this is one, I mean, before it was mentioned, the NIH Data Commons is one of the things that are able to integrate also with the NIH Data Commons project. So how that works is that deposit, I mean, you have a data file, you can choose from one of those tags, you might go through, we're building some tools to help you decide on what is the right data tag for your data, but also might be a committee that will help you to assign that. You provide a data use agreement with your file. Let's say that this file is orange. So in this case, the data tag is assigned, and you can just go through, just based on an orange data tag, you will need to register, and you you need a password, and you need to have an approved, a signed data use agreement in order to access it. So you have to be given approved access to access that file. But we're also working in collaboration with the Harvard Privacy Tools project that with some tools that would allow you to do analysis on the data without actually ever accessing the raw data. And those are these differential, I mean, one of the examples is a differential privacy tool that adds, in some way, adds some noise to the analysis, a small amount of noise, enough to guarantee that you would not be able to identify an individual or some information about one of the rows in the data set, okay? So this is very exciting, project that we're hoping 2019 to have it be able to be used by the community. We're integrating and testing it now. So one of the recent grants that we got, just by the way, that one was supported by NSF, and the one on the structural biology is funded by the Hensley Charitable Trust. This one on integration with reproducibility tools and generally in enhancing the data quality and data reuse is funded by the Alfred Sloan Foundation. And it has different parts. So one of them is the integration Dataverse with CodeOcean. Any of you know about CodeOcean? I feel like I'm introducing a lot of terms that many of you don't know about. It's a relatively recent, maybe 2 or 3 years ago, tool that allows for an easy online, running your code online, just depositing the code and be able to get scientific code and running together with data. So the idea here that we're integrating with them is that you have a data set that includes the data code in Dataverse, which many data sets have. It just works as a package of data and code, right? That you can upload, just say open in CodeOcean, run this, and just guarantee that everything runs and that it, the results are either as expected from the publication associated with the data set or from the results that are in the data set itself. So that is one of the things that, for example, some journals were interested or data reviewers were interested so that it would facilitate that computational reproducibility. We also work with a group that was Margot Seltzer, was a professor of computer science at Harvard University, but now is in British Columbia. And on this, on a provenance tool and a tool that it's called Encapsulator. We just published a paper on this. And what the idea of the encapsulator is that for now it works in R within either from RStudio, from the R language, so that you could, if you're running code and data, it creates a time capsule that has the data, the code that you use in an analysis, plus the provenance file, which is an XML file that follows the prof's the W3C Prof standard, right, ontology, so that it describes what files did I use as the input, what code did I use, what should be the result file, right? So all this becomes a time capsule that you can deposit to Dataverse or repository to preserve the analysis that you ran for a study, right? So this is still relatively preliminary. It's not yet integrated with Dataverse, but we're working with this group to create this time capsule. Another group that we're working on as part of this big grant is with the Odom Institute and UNC, which they're creating a tool that is called Core2 that helps, also puts all these tools together, reproducibility tools, and so, but it helps the communication with data reviewers, journals, data repositories, and so it helps to manage all these to make a review of a data set and code more efficient. And finally, I'll talk about this also project that just like a couple of weeks ago was we got awarded. That it's on well, it's funded by IMLS, the Institute of Museum and Library Services. And the idea here is that, well, we'll make use of a lot of the work that has already been done in this area, but doing a more quantitative study to analyze what would be the variables that you would define to describe an open source project and also an open source project. So in a quantitative way, and we want to bring a community of experts and open source developers and users to help us define that criteria better, but then do, again, a quantitative review of different open source projects and see how it helps us to see what works and what doesn't work and what is missing, what is not missing. And not in a sense of destructive about a project or discouraging. It's actually similar to what we're doing also with the FAIR principles, there's findable, accessible, interoperable, and reusable data. Just to create a set of tests or automated ways to see if I ask for all these questions about an open source project, are they doing this or not, and can I quantify what they're doing? So to give you a quicker way for yourself also to see what is that I'm missing that I could be doing. Is it important to use a certain set of tools to communicate, to get more engaged with the contributors? Is there other thing? Is the part of transparency, openness that is important? How open I am with what we're doing as a project and so. So we'll see what happens with that. For now, it's just a short pilot for a year to see if it's worth coming up with this health index for open source projects. And I welcome any feedback from any of you. If you think this is a very bad idea, please let me know. So, well, I'm done with the presentation. Thank you very much, and open to questions. Oh yeah, now we have this fun thing that we can throw to any of you who have a question. Please ask a question so we can throw this.
I don't know how good I am at throwing, but are you good at catching?
Oh. Hello? Whoa. Hi. So we run a gateway that works with social media data. And so, one of the issues with social media data for research is, well, most of the time people don't post the actual data that they researched with because of terms of service, issues with regards to various platforms. And then also, like, there's the privacy issue, right? Where we're using real people's social data. And so we've been thinking about what we call a non-consumptive research reproducibility environment for the data, where You put it behind a wall. You can do certain things against the data to kind of play around with it to check it, but you don't actually have access to the data. It sounded
Right.
very similar to the privacy.
It seems like similar to for differential, what do you use for that? Because there are different approaches. For example, with differential privacy, there is an approach that is more, it's called as a data curator, right? A curator that is the intermediate. It seems like similar to what you're describing, an intermediate agent that submits the analysis, right? But when it returns it to the user, it returns it with some additional small noise that don't change the quality of the result, but it just doesn't allow to. I mean, you still have to have what we call a privacy budget. So you cannot ask so many questions that eventually you will learn about some private information, right, or sensitive information. So, but within that budget, you can ask questions about either summary statistics or run a linear regression or run some model, some statistical model or machine learning model in the data.
Yeah,
so it might be similar. It would be interesting to see what you're doing. This group is quite large. It's a big collaboration with the School of Engineering at Harvard and a few other groups. And the census, the US Census is planning to use this differential privacy tool for the next release of census data.
Excellent. Yeah, I'd love to connect on to see if there's.
Yeah.
Great. Thank you so much. I don't think I can throw. I'm definitely not.
Thank you. Throw it. Yeah.
Thanks for a great talk. I'm with Quasi, and we have a gateway primarily for water-related data, models and code.
Yeah.
So a lot of this was extremely applicable to us. I'm curious if you could talk, you kind of mentioned this a little bit, but the level of curation that you provide for the data sets.
Yeah, and I was planning to put some slides on that, but there's so much to talk about.
Yeah.
So actually within my team, besides the entire Dataverse team, besides the developers and QA and usability group, there is a whole data curation team. And now we're working closely with the Harvard Library and other folks in the community that are interested in this data curation. So we do, I mean, we just try to first put a very low bar just to invite and incentivize or make it easy for researchers to just upload the data as it is. Right. But we are finding that, I mean, part of this data quality project is just to see that having that data curation, then that data is more reusable, right? So this group is now creating these different levels of data curation services to help. I mean, some low-level curation is done for free as part of using the repository, but if just to help organize what metadata you provide, how you organize your data files, so it's a service we're figuring out how to provide it. We've been doing as a pilot for small groups. Mm-hmm. The UNC also has a group that provides data curation. There might be other groups that provide that as a service, but it's one thing that part of this global consortium we want to provide to help as a service to researchers, because often it's 80 or 90% of the time you spend cleaning the data and curating it in a way that they can be reused, right? And can be analyzed directly, so it's very important.
Right. Thank you.
All right. I have a couple of fairly predictable repository questions. One of which would be, like, do you provide best practices for folks when you're thinking of, say, 15 years out, never mind 50 years out, on how is this data going to be accessible and useful? Question. And then sort of the second question is related of, are you guys still going to be here in 15 or 50 years so that this data is still available to be used?
I'll be kicking. No, we can never guarantee 100% anything, right? We could all be gone tomorrow. But yeah, we do, I mean, this just to differentiate what Dataverse is. So as an open source project, you know, is one thing how it, I mean, part of growing the community is part of our sustainability plan, right? Creating this consortium and organization that will help to continue promoting the growth of the community, and so service the community is part of our sustainable plan. But for the repositories themselves, then it depends on the hosted organization, right? So I can talk for Harvard, and there are some, well, Harvard always tells me don't talk for Harvard, but I mean, I can talk for the Harvard Data Repository. I cannot talk for everybody in Harvard. But so we do have a succession plan. So we're part of a data pass consortium or agreement with a few other archives. So, I mean, for one thing, we just provide archival of data into multiple locations and so on. So some of the Dataverse repositories have integrated with Archivematica or some other tools to provide exporting the data with preservation metadata files and so on. So, but more importantly, for this group of 5, maybe now we are 8 different organizations or archives, if one of us would not be able to exist anymore, the others would take the data. And I think that's part of why it's important, these standards and metadata and APIs to be able to export everything and be able to have a copy in another location when needed. So we do think about that. It's something that is, again, Dataverse started very much from a group that were archivists in some ways. So that has been an important part of what we do.
Oh, thanks. Anybody want the box? Right? You ready?
It's pretty, okay. Thank you for that very interesting talk. And my question is, I noticed you had Open Science Foundation as one of sort of your collaborators. And I know they do things that are kind of similar. They help researchers publish their data as well as the metadata from their papers and so forth. I'm wondering how does your organization and OSF sort of combine to
Right.
add
I mean,
features?
in a way, yeah, some of the things, it might be duplication of features, right? It might be an overlap, but and at the same time we complement, I think, each other very much, because the OSF doesn't provide, I mean, it's not a data archival, right? It doesn't focus on as a data repository to provide all the features that are associated with sets and so on, managing different, like I was describing, restricted data, managing be able to extract, for example, information from data files, from variable metadata, right? And providing extensive metadata that is focused on data sets. So it's more for organization of the entire project. It's very useful for saying, here I have a research project and here are all my files that I'm working with my collaborators on that project, and I can, if you want, you can make it open from the beginning. But when we worked with them, we thought that it was, I mean, part of the integration was that they were happy to have that option that from open science framework, you could go and deposit the data in a repository that will take care of a data set from an archival way. I think that's the difference. Maybe OSF sees it differently, but I think that's why we've been complementing each other in some way.
Thank you.
I mean, there are other solutions that are similar to what we have. There are some overlaps, obviously.
Just a quick one, not to hold us up from the coffee break, but thank you for a very thoughtful talk, Mercè. Yeah, I was making notes throughout the talk of overlaps to the Gateway community.
Great.
One thing that struck me that both you and Joe mentioned that had really never occurred to me before was this, I think you called it differential privacy, where you can compute on the data, but you can't get access to data. Yeah. That seems to me like a tremendous opportunity for a gateway-like thing, right? Where you can't serve up the data set. And so just really like to be involved as that moves
Perfect.
forward in some kind of way. So,
Perfect, perfect. Yeah, we'll talk about that. Yes, I think there are the solutions like the synthetic data or other things like that. But I think differential privacy in the last years has been showing that it actually has a potential to work, at least for some data sets, maybe not. But it's great. Yes? Yeah. Good. Thanks.
Well,
Thanks, everybody.
Yes. Yeah, let's give her another round of applause. Thank you. And thanks for all your thoughtful questions. I'm sure she's willing to be cornered in the atrium during the coffee break to be asked more questions. I wanted to thank you, Mercè, so much for coming all the way out here too. And this is a small gift as a thank you for that.
Thank you so much.
Yeah,
It's
it'll weigh down your suitcase a little bit, but hope you like it.
Good.
So thank you very much.
Thank you. Appreciate it very much.
Yeah,
I've been very nicely welcomed here, so I like science. Okay, we'll work together.
Awesome, thank you.